This equation is an example of what we call a rational equation. The rational numbers are numbers that can be expressed as a fraction. When we have an equation then that contains fractions, we call it a rational equation. Our technique for solving rational equations is to find the least common multiple for the denominators of the fractions. And we will use that as a multiplier to multiply both sides of the equation. That will enable us to cancel out those denominators in those fractions and create a new equation that no longer has fractions. It's much easier to solve equations without the fractions in general than it is to deal with the fractions. In this case, my least common multiple has to have x, so that when I multiply these two fractions, the x's will cancel, and my least common multiple will have to have 3, so that when I multiply it times the fraction 1/3, it will cancel the denominator 3. So I'm going to use 3x as my multiplier here. I'm going to multiply both sides of the equation by 3x. That means I have to distribute that multiplication times each of the terms that are in the parentheses. It will be 3x times 4 over x plus 3x times 2 equals 3x times 1 over 3 minus 3x times 1 over x. Now let's multiply in each of these instances. 3x times 4 over x. Well, remember what you do when you multiply with fractions? You first see if you can do any canceling. This is like having 3x over 1. Won't those x's cancel, just leaving us 3 times 4, which is 12, plus 3x times 2 is 6x, equals, here, the 3's will cancel, leaving us x times 1, which is x. Here, again, the x's will cancel, leaving us minus 3 times 1 is 3. We've created a nice linear equation we can now solve. We've gotten rid of those fractions that were making the problem look more complicated. Let's subtract x from both sides as our first step now in solving this linear equation. So 12 equals 12 plus 5x equals negative 3. Let's subtract 12 from both sides. 5x equals negative 15. Dividing both sides by 5, we get x equals, dividing both sides by 5, we get x equals negative 3, not negative 5. I did that on purpose just so that you know I can make a mistake once in a while. So our solution to that original equation is x equals negative 3.